In this video, we look at a problem involving graphing exponential functions. So first off, we're told describe the transformations that must be applied to this base function, y is equal to 3 to the power of x, to obtain the function that we have written here. So the first thing to identify is how is this function related to the base function? The base in the exponent here is the third, whereas the base in the exponent in this function is 3. So one of the things to notice is that we can rewrite this as minus 2 times 3 to the power of minus 1 to the power of 12 minus 3x plus 2. Now we can use the exponent laws to simplify this. 3 to the power of negative 1 to the power of 12 minus 3x, I can just write as minus 2 times 3, and I can multiply these exponents because I've got an exponent to an exponent, so I'm or a power to a power, so I multiply the exponents using the exponent laws. That would give me 3x minus 12, because 12 minus 3x times negative 1 is just 3x minus 12. It just changes the sign on each of these terms. So we have minus 2 times 3 to the power of 3x minus 12 plus 2. So another thing to note is that if I write out the transformed function for an exponential function, notice that I have the k value factored in the exponent, and here my k value is not factored. So this is equal to minus 2 times 3 to the power of 3 times x minus 4 plus 12. And here I've factored out the k value. So now I can identify what a is, what k is, what d is, and what c is. So here a clearly has to be negative 2, k is 3, d should be 4, and c is 2. So let's look at what these values actually do. Here I've written it out just to save some time. So a being equal to negative 2, we looked at in the last unit that this is a vertical dilation, or a vertical stretch by a factor of 2. Since a is negative, it's also a reflection in the x-axis, or a reflection about the x-axis is another way to say that. K is equal to 3, so this is a horizontal dilation by a factor of a third. Or we could also say that it's a horizontal compression by a factor of a third. D is equal to 4, so this is a horizontal shift 4 units to the right. C is equal to 2, so this is a vertical shift 2 units upward. In the next part of this question, it tells us to write the mapping rule. So remember that for the mapping rule, if I have a point x comma y, it would, on any graph, it'll, and I know what a, k, d, and c are, this point will transform to the point x over k plus d, comma a, y plus c. So we already know for our function what all these values are. We know that k is equal to 3, so we've got x over 3. D is equal to 4, so I have x over 3 plus 4, comma ay plus c. A is minus 2, so I have minus 2y plus c, which is 2. So x comma y transforms to these coordinates. So let's go ahead and do that for the coordinates of the base function, which is y is equal to 3 to the power of x. So the key points on y is equal to 3 to the power of x are negative 1 comma a third, 0 comma 1, and 1 comma 3. If I plug in x into this equation here, if I do minus 1 over 3 plus 4, I should get 11 thirds. And 1 third times negative 2 plus 2 is 4 thirds. And 0 divided by 3 plus 4 is just 4. 1 times negative 2 plus 2 is 0. And 1 divided by 3 plus 4 is 4 thirds, or 13 over, or sorry, 4 1/3 or 13 over 3. And negative 2 times 3 plus 2 is negative 4. So these are the key points on my transformed function. The other thing that I need to take note of is where is my horizontal asymptote going to be? And my horizontal asymptote is normally at y is equal to 0, but remember that this function has been transformed 2 units upward. So that means that my new horizontal asymptote is going to be y is equal to 0. Or that's the equation of the horizontal asymptote. We'll finish this example in the next video.